Nothing truly lasts. Even the air you're breathing changes identity, rewriting the universe right under your nose. But do you know why? Strap on your goggles. It's time for CurioLab. Every second, inside your body, particles are changing who they are. That's the weak nuclear force at work. So what does it actually do? The weak nuclear force governs how particles change when staying the same no longer works. In some nuclei, like carbon-14, there are more neutrons than can be held stably. That crowding stores extra energy, and the balance breaks down. Inside a neutron, matter is made of smaller pieces called quarks. The weak nuclear force allows only one quark to change its type. A down quark turns into an up quark, turning a neutron into a proton. Because a neutron is made of 2 down quarks and 1 up quark, whilst a proton is made of 2 up quarks and 1 down quark. Change 1 down quark, and the particle's identity flips. Just 1 quark is enough to shift the balance. Anything more would release too much energy and overshoot the balance again. Energy is released and leaves the particle as new, tiny messengers. One of them is an electron. Another is a nearly invisible particle called an antineutrino. They carry away energy and motion, allowing the nucleus to settle into a new, stable state. That quiet change is called beta-minus decay. Turning a neutron into a proton creates extra positive charge, so an electron must appear to balance electric charge. But the weak nuclear force can also do the reverse process when protons are in excess, or there are too few neutrons to stabilize them. A proton can turn into a neutron through beta-plus decay. Turning a proton into a neutron removes positive charge, so a positron appears to balance electric charge, while a neutrino carries away energy. Or, if there is not enough energy, the proton can capture an electron instead, in a process called electron capture. No positrons are emitted here, only neutrinos, because the proton and the electron already have opposite charges. And it's how matter learns to move forward, by rewriting its identity from the inside. Neutrinos don't respond to gravity in a noticeable way. They don't feel electromagnetism. They don't stick to the strong nuclear force. The weak nuclear force is the only force they interact with directly. Because of that, neutrinos can stream out of the sun's core, from exploding stars, and from the earliest moments of the universe, carrying information with them. The weak nuclear force makes the universe reveal its quietest stories. The tricky shapeshifter isn't loud. It doesn't show off. It just waits, and it changes everything. And that's all for now about the 4th member of the Power Squad. Watch the other episodes to see how the universe truly works together.